Well, first of all, thank you very much all for coming. This is an event which is not, it's slightly unusual compared to the traditional scientific meetings. It's not a scientific meeting. It's an open meeting for the public at large, whether there are with science interest in the matter, but also for lay people. So it is a new way in which we try to disseminate what we research in lay language to people that really the end beneficiaries of what we do. My role today in a sort of three-way game, and I'm very sorry that these folk couldn't make it for obvious reasons, is to set the scene for the next two speakers to dwell into the importance of sleep with aging. I'm trying to give you an introduction what is the connection between sleep in terms of sleep disturbances, and I will define what we mean, in relation to ill health in general. To give you an idea that what we will focus later on cognition is the end of a long line of research we've followed, and it's not the only thing that goes wrong when your sleep is disturbed. So there will be a number of questions I'll try to answer with very simple slides, and some of these questions are very obvious and very basic. Just to make you think, first of all, sleep as a function is a function that we all have. There's no one exempt from sleeping, and takes 1/3 of our lives. So it is a pretty important exposure, something that we should be interested in. What is sleep has changed over the centuries. The perception of sleep has been for many, many centuries, and those who come from humanities may know what I mean, where sleep equates death, was a state of death compared to a state of being alive when you are awake. And it comes from the Greeks, the Romans, and up to Shakespeare. More recently, in modern science, there's been a surge of interest in the study of sleep, which only come after the 50s. Before the 1950s, the only association between science and sleep was really invigorated by the studies of Freud and Jung. And that really was sleep in a sort of the mind and the dreams, rather than the physiology. The reason why is that in the late 50s, for the first time, some of the biological structures regulating sleep were discovered. So until then, it couldn't have been studied in any different way. What are the basic facts of sleep? Sleep is a universal phenomenon. We all sleep. There are extremely rare situations where people genetically cannot sleep. And they're really so rare because they're fatal. And so if you don't sleep, you die. If you take an animal experiment and you stop them from falling asleep, you kill them, quite. And in fact, sleep restriction to the level of extreme sleep deprivation is now considered by the United Nations as a crime, and is one of the forms of torture that is used by many countries. So just to put in the context of how fundamental sleep is for our functions. And everybody and every creature sleeps. Now we're looking at animals, but plants seems to have a cycle which could be considered some sort of sleep. And I'll show you some very basic creatures that also show evidence of sleep. If there is no sleep, there is death, as I said. It is a state of vulnerability. When we sleep, sometimes we are subject to the risks of nature, and there are species of animals, for instance, that have developed in their brain the ability to have half of the brain asleep and half of the brain awake, so that they can really control predators and other things. So it's fascinating. Why do we sleep? Well, let's see. I'll show you this is a cockroach, and this is an awake cockroach. And you will agree with me. It is awake, isn't it? You're laughing. Why are you saying not? What doubt do you have it is not awake? how am I so sure that he's awake? Well, I'll show you what a cockroach asleep looks like. And now, do you agree with me that it looks more awake and this is asleep? Well, we'll touch upon what are the features here in this very, very basic creature that is shared with human beings to make us think that this is awake and this is asleep. And in fact, obviously, a living creature shows a circadian activity inactivity cycle, which can be considered sleep. In particular, note in this cockroach, the antennas are stretched, is up on the legs, the head is up. And in this stage, the legs are retracted, the antennas are relaxed, the head is down. So some of the features of sleep can be seen in animals closer to us. This is our cat. How many of you own a cat in a house? So you're very familiar to these shapes. You can know exactly what they're doing. This is an awake cat, but this is a cat asleep during the non-REM phase, and this is a cat asleep during a REM phase. How do I know that? Okay, scientifically I know because these are different stages of sleep. When we fall asleep, our brain goes into different phases, whereby at some stage we are, some of the functions of the brain are still alert, some of the muscles are still active, and later on we go in a different stage of sleep when we can dream, and some of the functions change. In fact, the REM, for those who are not familiar with, means rapid eye movement sleep. And the reason for being that during this side of sleep here, our eyes stay still, but during the REM sleep, one of the characteristics of this, that we dream, our eyes start moving very rapidly, left and right, and we are subjected to what we call a muscle paralysis. You see, the cat is now completely relaxed. And you may know when you are asleep, if something happened to you that you're feeling, you jump in your bed, you're feeling you're falling. Have you ever happened to you? Well, that is because you change your phase of sleep. You become more superficial, but your muscles are still paralyzed. You can't move. And that is the feeling you have of falling, because you have no control of your muscles. Going back to the cockroach, those are the signs that I think that the cockroach is asleep. And we can identify these different activities during sleep. So sleep is not an idle activity. There are many things happening in the brain, but not just in the brain. And this is becoming more apparent. It's happening in your muscles, in your eyes, in your heart, but it's also happening now in other parts of your body. All these sleep functions regulate hormone productions. Your adipocytes produce enzymes and cells and cytokines according to where you are in the phase of your sleep, and so forth. And that's things we've been studying more closely, and we've been studying the consequences of those changes. So the first thing to say, yes, we'll discuss about cognition later on, brain function. We all associate sleep to brain, but my role here is to tell you, although you will hear a lot about it, sleep is not just affecting the brain. Sleep does not mean just the brain. That means many other things, as I'll show you. How do we know when we fall asleep or not? That's one of the functions that is regulated by a biological clock. To give an example of what these very highly specialized cells sitting at the center of our brain in a place called hypothalamus, really the center of our head. There are few hundred cells. Consider we have billions of cells in our body. And these highly specialized cells are only about 5 to 800. Tiny number. These behave in a way that kick automatically with no particular relation to feedback system, a bit like your pacemaker in your heart. Very similarly. Your heart beats primarily because a little bunch of cells in your heart kick a rhythm, an electric stimulus. And then gives the heart the beat, and everything starts from there. Likewise, the little cells give a pulse to give you the 24-hour cycle. And from that, everyone else comes, every other function comes into tune with those systems. And if you have derangements of your sleep, obviously your functions will not be in tune, or as we say, entrained with those paces. Now, we decided many years ago to start a program at Warwick that was going to extend the studies of sleep, not just to the brain, to the cells, and to the biology and the physiology, but to the effect to society as a whole. Because we all sleep bad or well, we all sleep too much or too little. And so it affects everyone. But no studies have really addressed the perspective of what is if sleep is modified, what happens in the long run to our health. And so we started the program, and it's a large program, which now affects many different areas. I will show you some of our studies progressing on the link between sleep problems and chronic disease, the commonest diseases in our Western world. Heart disease, high blood pressure, diabetes, obesity, strokes, you name it. I'll show you a few data. But also later on, we will touch upon mental health in general, but most specifically on a study that's just been released this morning in the press on cognition, on brain function. Now, all starts from some observations. These are young people studied across the world. These are young college students taken in different countries with the same methodology. And very simply, they were asked how many hours on average they were sleeping at the time they were interviewed, and how they were reporting their health. So self-reported health. Was it poor? They were happy? They were well or not? A large number of it. This is in excess of 15,000 people. And as this slide shows, there is a sort of constant poor health, self-reported poor health, about 10%, whether you sleep 7 or 8 hours per night, doesn't matter. But as you move down to a lower duration, shorter duration of sleep, you find that the proportion of young people reporting poor health increased up to about 40%, indicating some possible association for reasons that are not clear by this study. So, short sleep seems to be associated with poor self-reported health. Later on, we went to study some of the relationships between duration of sleep and obesity or weight in children, adolescents, and adults, because there were some reports indicating that if you sleep less than a certain number of hours, you tend to gain weight. But we were not sure, so we tried to look at all possible studies. We looked at mechanisms. And we came up with this particular graph which summarizes several studies. And this shows to you what is the potential link between sleep duration and obesity. And that is the tricky situation we are in when we do research. From one side, we know that if you sleep less than you should, in children it will be less than 10 hours per night, in adults less than 6 hours per night, you tend to have an increase in energy intake, so you eat more, or you burn out less. At the same time, you reduce energy expenditure. And that is through some mechanisms of increased appetite, for instance. Not sleeping enough will trigger you hunger. You will shut down the hormone that makes you feel full and will trigger the hormone that makes you feel hungry. And they work in a seesaw mechanism. So eventually, your hunger increases. And also, if you don't sleep as much, you probably have more chance to satisfy that hunger. And tell me, if you indulge in an extra hour a night, you'll probably spend in front of the TV snacking rather than in the gym. So, and for children, this is the case, which really will fuel the story that short sleep will lead to increasing weight, which is a fact, can be demonstrated. However, it is also important to consider, and that's where we fall into some traps when we do research, that being obese by itself will affect your sleep. As you become obese, overweight or obese, your breathing is impaired, you tend to snore, to have fragmentation in your sleep, and eventually you sleep badly and you sleep less. So there is what we call a bidirectional model. Sleep can cause obesity, but obesity will disrupt sleep. What are the metabolic consequences of this? As you know, obesity is one of the major risk factors for diabetes, and that goes through some derangement of the metabolism of insulin and glucose. Now, I don't want to go into too much technical details, but definitely the imbalance I showed you between appetite and energy expenditure leading to obesity eventually creates a situation of insulin resistance and glucose intolerance, which is the landmark or the hallmark of type 2 diabetes. And we have carried out some studies showing that those who sleep less than 5 hours per night have about a 25% increased risk of developing type 2 diabetes. So our studies have gone through the study of the association, for instance, between short sleep and hypertension. If you don't sleep enough, you develop high blood pressure more often. And sadly, this is stronger in women than it is in men. And we also studied some of the mechanisms that are involved in determining these, because short sleep affects, as I hinted earlier on, hormone production, cytokines, inflammatory markers, which will lead to these conditions. Now, I have to say, we also, our program, wanted to test, does that all relate to the important outcome, heart attacks, strokes, and deaths? I'm sad to say that we are famous in the world at Warwick for having provided this evidence, which is quite damning, because if you tend to regularly sleep less than 5 hours per night, I'm afraid in large population studies we've been able to show that you end up with a 20% higher risk of developing diabetes, a 48% higher risk of developing coronary heart disease, whether fatal or non-fatal. You develop a 50% greater risk of stroke, fatal or non-fatal. But more importantly, you got a 12% chance of dying earlier than you should. So sleep is important. And this evidence I just hinted to is very strong, is consistent, and is biologically plausible, suggesting that it's possibly there is a cause-effect between the two. And I just want to acknowledge in the program the support and the collaboration of a huge number of people over the years. We now are in our 9th year of the program. And over the years, we have collaborated internally, externally, nationally, and internationally at different levels to produce this evidence. Thank you.